I'm Crispin. This is David. I'm a PM, so I'll do the fluffy part and he'll do the hard part. Outline of our talk. Today we're going to talk about how to build trustworthy apps. The platform has some lovely built-in protection that helps make your apps more secure, but there's definitely stuff that app developers can do too to help make them more secure. Focus on capabilities. David will focus a lot on web application security because that's a lot of what modern apps are about. And then a little discussion about app data sharing. It's always the sharing, isn't it? And finally, we'll close up with what's really new in this platform model. So the security proposition of the Windows Store is that users should have confidence in apps. They should be confident that they can try and buy any app they like, as many apps as they like, and bad things don't happen to them as a result. Contributing to this confidence, we have the store's onboarding analysis where they're going, oh, is this a piece of crap? Well, yeah, maybe we better not let it on. We've got the Windows 8 platform mitigations that keep the app from hurting your PC and from hurting you. But what about your app? The developers need to participate in making the app itself be secure. So the store, in its onboarding process, does a baseline for quality and reliability. They boot it. The store has a reviews and ratings mechanism, so if an app sucks, then presently everybody knows it and it doesn't get bought so much. The store model discloses the capability permissions of this app is going to use your camera and your microphone, and so you get to know that stuff before you make the purchase decision. And we have telemetry, so if the app is doing something mighty peculiar, the store finds out about it, and if necessary, we can kill apps that are misbehaving. The app developer's role. It's often misunderstood that the app container part of the platform is not a castle, it's a jail. It's designed to prevent breakouts. It doesn't do anything to prevent break-ins. Therefore, apps can be attacked almost as much as they ever could, from the network, from neighboring apps, from the clipboard. And apps that host powerful resources are attractive to attackers. An attacker may well want to go after exploiting that app instead of exploiting your box because that app has the password to your Facebook page, or worse, your bank account. So what can you do to secure this stuff? First of all, the platform tries to help you. Throughout the last decade, MSRC and Windows have built a bunch of fantastic memory exploit mitigations, /GS, ASLR, DEP, SEHOP, that sort of thing. But almost always they are not on by default because they have some little compatibility issue over here and over there. And if we turned it on by default, then somebody's app would break, and Windows is all about compatibility, so we can't do that. So they're always opt-in, and opt-in means that on a good day, 30% of developers do. Windows Store apps, this is a new platform. You don't just expect code to run it. You actually have to port it there. So breakage is expected for legacy code, and therefore we can turn these things on by default. And if it breaks your poor boo-boo app that's still living in the 90s, then that's too bad. You better fix it. And so as a result, at least, you can have confidence that every app that you run in the Windows Store has all the good memory mitigations turned on and then some. You want to minimize your capabilities. Each app in the store includes a set of the capabilities that it manifested. I've chopped them up into roughly 3 or 4 classes here. The file capabilities give access to libraries. You may not have even noticed libraries before in Windows because they were sort of not that exciting a feature that you don't have to notice if you don't want to. But when it says My Documents and My Music, that's not just a folder. That's a feature. You get to include as many folders as you want in My Documents and My Music. And what this capability does is it says the app gets to access programmatically every file that's in the pertinent library for each of the 3 file capabilities. Network capabilities, we've got 3 basic coarse clumps of firewall access: internet client, intranet client, and private network. Oh, and proximity, so there's 4. The device capabilities for webcam, microphone, location, and enterprise capabilities. And you want to minimize these because the more capabilities your app has, the more damage your app has the potential to cause if Charlie meets it. The special use capabilities, which I'll get to, they cause the App Store to do closer inspection of your app, which may lead to a delay in publication. And so stay off the radar if you don't need that stuff. Security-conscious users may look askance at an app that is manifesting more capabilities than one might expect. And of course, most users aren't going to do that, but you are, right? You look at the capabilities on your apps before you buy them. And attackers may be interested in attacking your app to obtain these capabilities. So unless you need a capability, just don't use it. That's the GUI in Visual Studio for turning on the various capabilities. Internet client is on by default because what's an app that doesn't have internet? Well, there's a piano app in the box, but not much else. So when to use file capabilities? You need this when you're going to do playlists. So if your app just needs to access a music file to make a noise, please use the file picker. It's a nice file picker. And that keeps you out of trouble. You don't need to declare any capability. The user can pick any file anywhere. No capabilities. You need these capabilities if you're going to do a music player and then you want to have a playlist and it wants to go through all of your Beatles songs, and it would just suck to have to go back to the file picker to pick the next track of music. So if you need to do that kind of programmatic sequential access of lots of files, then the capabilities are called for, but not just because you use files. And especially, some people try this, don't declare a capability and then stash all of your app state in the library space. Put your app state in your app state space, because the user actually expects it, that when you uninstall your app, it takes all of its stuff with it. There's the file picker. It's a nice visual, touchy, friendly thing. When to use network and device capabilities. The network, mostly just use internet client. That's the simple thing. It lets you be a web browser. You can go and send requests to whatever you want. You need internet client server if you're going to do peer-to-peer things. So if you have a chat app and it's not strictly server-based, you're actually going to have the 2 chat clients talking directly to each other. You're going to need internet client server. Basically, that lets you punch holes in the firewall and call listen. And you need private network if you expect your thing to work on a LAN setting. So if you're a high-performance game and the user is supposed to use this in a LAN party, if the app is an enterprise line of business app and you expect it to be able to access corporate resources on the LAN, then you need private network. Devices are pretty obvious. Only turn them on if you want the relevant device: microphone, webcam, etc. And the enterprise capabilities are enterprise authentication and shared user certificates and the documents folder. Enterprise auth lets the app identify across the wire as the logged in user if the machine was domain joined. So it's not even relevant if it's not a domain joined machine. And that's very powerful and useful if you wanted to write an HR application so that your employees can go and access their paycheck. And it's kind of a good thing that Angry Birds doesn't get to go and access your paycheck. And now it's David's turn.
All right. So I'm going to talk about the web security aspects of the platform, the things you need to think about as an application developer or in testing your application to make sure that it's secure. So first, talk a little bit about the attack scenarios you need to think about, and then talk briefly about the fundamentals of the security model at this level of the system, just so you kind of get an idea of what are the things that the platform mitigates on your behalf, what are the things you as an application developer really need to go out and do. And then we'll talk about the fun stuff, the security techniques, and the things you need to watch out for in code, and how to mitigate issues when you identify them. So first, when I look at specific apps, is with my pen tester hat on, even if I see the capabilities model that's there, as Crispin talked about, Minesweeper may not be particularly interesting, but on an interesting platform, an interesting platform will have interesting applications that will do interesting things with your data in the cloud, on Facebook, on anywhere, in other locations. So you have to start to think about, how's an attacker going to leverage that and exert control over your application, or how are they going to affect that relationship with the user and the application that you're building. And the primary vector that we've seen is cross-site scripting. And then you sort of have to think about where in your application is external data coming in, and you have to worry about injection that's going to run script within your application and do things with the access that particular application has. So you can kind of run down the list of interesting sources of data coming into your application. XML HTTP request, of course. You have the HTML5 post message API, and we'll talk about the security contexts that different windows within your, or different frames within your application have. And post message is interesting because you have data that's crossing security boundaries there. WebSockets, RSS and Atom content, all of this, there's information coming into your application from many different places. And this the list goes on. Crispin's going to talk a little bit about sharing contracts, protocols, and file extension handlers, which are unique to Win8. And then there are other more interesting vectors. You can imagine SMS messages coming in, and obviously your application is going to need to handle that securely. So the next thing to think about is, how is an attacker actually going to manipulate the external data that's coming in? And those are sort of the attack scenarios to think about. First one shouldn't be much of a surprise, just the man-in-the-middle scenario where you open your laptop at Starbucks, somebody's affecting that data that's coming into your application. They're monitoring it and also potentially able to modify that as it goes into your application. Your application needs to be secure against that threat. And then, of course, if you have a scenario with a compromise, if your server gets compromised, that may now affect the application. You don't want a compromised server to lead to applications enabling webcam access, that kind of stuff. And then you can also imagine that even the data itself may be compromised. So if you have an RSS reader that's pulling down content from all over the web, that if one of those RSS feeds is malicious, you don't want that to have an effect on your application and introduce cross-site scripting. So we'll talk a little bit about the fundamentals of the security model at this level of the system. And really, as I mentioned, this is about this is to enable you to sort of figure out, okay, what is the system going to provide for me, and what do I really need to do as an application developer to mitigate threats. So the system attempts to address sort of historical cross-site scripting scenarios that we've seen in, this is not the first platform to leverage web technologies. And so, the first thing that would come to mind in that context is just taking some markup and putting it directly in the DOM, and then script within that, say a script tag within the markup, executes, and boom, you have cross-site scripting. Of course, we've also seen many other script execution vectors that are interesting as well. So for example, if you take a JavaScript URL and maybe you properly encode it for that particular context, but you don't realize, oh, it's actually a JavaScript URL. It has the JavaScript prefix. If somebody clicks on that within your application, that would be interesting. Win8 mitigates that. We'll talk about that a little bit. And there's like a long tail of other scenarios like that. You may remember that in IE CSS content could use the expressions feature to run script. And so application developers in the past had to worry about referencing CSS out on the web and then having a man in the middle modify that CSS to include script. And so those are the kind of scenarios that that actually the platform is going to help you out. So in the development of the platform, really there was this design philosophy to sort of enumerate all the different vulnerability classes, like the JavaScript URL scenario, the CSS thing, and sort of provide a mitigation for each one of those that's on by default. There's one caveat here in that this is really only for inadvertent errors, not inadvertent things, not flagrantly bad application behavior. So if you're building an app and you download some script and then you call eval on it, like that's kind of, you just shouldn't do that. And we'll talk about that a little bit. And I just want to show the one-page view of what the security model looks like at this level of the system. It's really each frame or window within an application that's built on web technologies has a security context associated with it. So trusted content from the local package is in what's termed the local context, can be identified by the MS AppX protocol scheme. It has access to WinRT, but it also has some special mitigations applied that I'll talk about. And then pretty much everything else is in the web context. So that's everything with the HTTP URL scheme, HTTPS, whatever else. It's intended for untrusted content from the internet. And it doesn't have direct access to WinRT. It's really just supposed to be just like the internet zone in IE. And there's the HTML5 post message API, sort of the formal mechanism for passing messages between these two security boundaries, or between the security boundary here. So talking about those special mitigations in the local context, there's a number of them. I'll talk about some of the most important ones. Content in the local context needs to reside in the application package. You can't have script tags that reference external content. So you mitigate that man-in-the-middle scenario. Script URLs, like for example JavaScript and VB script URLs, are disabled. And then there is sanitization that occurs on various HTML syncs. Inner HTML being the most notable one, but I think there's about 13 of these. And that sanitization doesn't really happen automatically. What happens is if you take some markup that contains some script and try to put it in the DOM using inner HTML, you'll get an exception thrown if there's script in that markup. And then it's your responsibility as the application developer to call the toStatic HTML method and sanitize that before you go and actually put it into the inner HTML property. If you do that first and it doesn't contain script, then you'll be able to get that into the DOM and the page. And so now I'll talk about some of the security techniques that you can apply and the interesting, the things you're gonna want to watch out for in code and how to apply those techniques and the mitigations in your application. So I'm going to jump into a demo, but before I jump right in, I'm going to kind of show you what is actually happening. So I'm going to have Fiddler up to modify traffic as a man in the middle, and I'm going to launch an application that pulls content off of the network and displays it to you. And it has a bug that we've seen that is and a particularly interesting scenario and an example of where you can go wrong when you're building an application. So I know this is a bit small, so let's see if I can enlarge it a little bit. I don't know if. So what I'm going to show you here is basically the markup that I'm injecting, and then what the code is actually going to do within the application. And so you can see there's this line here that has an image tag. It's very hard to read because it's double HTML encoded. I wouldn't say that's what's making it hard to read. It's probably mostly hard to read because it's very small here. But it has an on-error event handler associated with it. And that on-error event handler, if it fires, is going to run some malicious script. And so what the application is going to do when it receives this, all right, the first thing it's going to do is create a div element. And then it's going to take that markup, put it within the div element, and then read out the inner text property of that div element. And effectively, what that's going to achieve is it's going to do one level of HTML decoding on this. And so now you have some markup that now is still encoded. And if it goes into the DOM again, it's still not going to execute. And that's actually exactly what happens another div element is created. The inner HTML property on that div is set to this markup. And then the application reads back the inner HTML property again. And so the comment here is mine. It looks like what the app is trying to do in this case is sort of leverage that platform level sanitization so that when they pull that markup back, or when they initially put the markup into the DOM, an exception will get thrown, and the app won't be able to inject script into itself effectively. And so what actually happens here is, because of what's actually in this markup, being a little hand wavy here, but the image, you effectively get an image tag back. It's a valid image tag, and of course, the next thing the application does is disable sanitization using the set inner HTML unsafe WinJS API, and puts this markup into the page, and script will then execute. And so, really, the guidance here is, don't take even if you think you're doing the right thing, don't take some markup off the web and eventually just insert it into the DOM after you disable sanitization. You really should be very careful about disabling sanitization. So I'll jump into the actual demo itself. Let's see if I can get this to work. So I've got Fiddler up and running right now. Here it is. And it's going to be modifying the traffic for me. And I'm going to go in here into my application. The application has a bunch of products and a bunch of people, and it's a socially connected application, so these people are supposed to comment on the products. And effectively what I've done is I'm going to replace the description of this particular product, the Excalibur 3900 Deluxe Food Dehydrator, one of my favorite products. Okay, so yeah, unfortunately, I'll have to log in again. It makes the demo a little less slick. And then let me go back in. Yeah, unfortunately, it lost my my token expired, something like that. But I'll go back in. It should work this time. All right, there we go. It works. Successfully contributed to your Facebook timeline. So you can sort of see in the background here this broken image that contained the script that executed within the application. I'm going to jump back out of here, and you can see on my desktop, I can go into Facebook. You can see that actually happened. So really, the message is about the sanitization, but I did just want to point out, let's see. This is really what you're up against when you're building applications. Here it is. Gotcha. So it did post to my Facebook timeline. This is really what you're up against. If your app is connected to Facebook or is connected to SkyDrive or anything else, then the attacker who injects their markup is going to be able to leverage that, even if they don't have capabilities to access your webcam and whatnot. In terms of the sanitization in particular, it goes back to this guidance to avoid the use of these APIs with unsafe in the name, such as exec unsafe local function and the WinJS API set inner HTML unsafe, which are going to, sorry.
Who'd have thought? Really?
Yeah, no. There is unsafe in there for a reason, in the name for a reason, and they disable sanitization. So the only reason you would want to use those APIs is where you're really in control of that data that's going into the DOM, and that you created it from static content, you didn't download it, and so you don't have an injection scenario. You do want to leverage the window.toStaticHTML API to sanitize markup that you put into the DOM. And then another approach is that you can sort of dynamically construct content in the DOM. Similar to the way that we saw this application doing it, you just don't disable sanitization. So this code snippet here basically creates a new div element. It sets the inner text property on that element, and then it puts that into the DOM, and that's safe. The next thing to talk about here is that you can use the HTML5 iframe sandbox attribute, and I've got a little demo of this. This actually provides you with a better level of isolation from toStatic HTML. And then it not only defends against injection of script, but it prevents things like the use of CSS to overlay other content within your application. So if that's a threat that you're concerned about, then it's something you can leverage. So I'll sort of show how this works. So okay. So I'm in the, I'm going to duplicate my screen. All right, so I'm in my application here, a little test application. It's got some markup. It's got an image tag with an on-error event handler associated with it. And that on-error event handler, similar to in the application I demoed, is going to run script if it fires. I also have a SVG circle with some CSS fixed positioning applied to it right here. So what I'm going to do is I'm going to take this markup here, and I'm actually going to try to inject it into the DOM in various ways. So the first thing that I'll try is to take that markup from the text area and inject it into the sandbox frame. You can see that script did not execute. I didn't get this dialog box that popped up. And I do get the SVG circle showing up within the iframe. So if I use the toStatic HTML technique, and this is just running the markup through toStatic HTML and putting it into the DOM. I don't get script execution, but you can see that the SVG circle did sort of appear outside of the boundaries of that div on the page, and so that's something to think about in terms of a spoofing scenario. So if you're concerned about that, you can use the HTML5 iframe sandbox. And then the worst thing to do is really to disable sanitization and insert this markup into the DOM, and that's exactly what I just did, and now script executes. So finally, oh great. Let's see if I can get the presentation back. All right. So finally, the last thing you can do is display your content in the web context as opposed to the local context. If you're going to display some content that you don't necessarily trust, then even if that executes script, it's not going to have access to WinRT. You can't turn on your webcam and that sort of thing. The next thing to talk about is you should never download arbitrary script and then execute it. For example, downloading a script via XML HTTP request and then calling eval on it. We see this primarily with JSON parsing. There is an API within the DOM, JSON.parse. You should use that. Don't simply download content and eval it. It's inherently problematic to do that. If you find yourself in some other situation where it looks like you want to do that, really what you want to do is include all that app code all the code that would show up in the local context in the application package itself. Just avoid downloading script and then executing it in the local context. So the next thing I want to talk about is the mitigations in the platform around man in the middle in general. So of course, lack of secure transport enables man in the middle. Users, one thing to think about is that users sort of inherently trust content displayed within your application. There's no address bar and a lock icon as you would have in a web application in the browser. So you really want to be careful about what you display. If you display a huge frame pointing to some arbitrary web content, maybe it makes sense to decorate that frame a little bit with some description as to what's in that content, so users know that's not really part of your app. You should use HTTPS, of course. The platform allows you to enforce HTTPS on navigations using a meta tag that you can apply to pages within the application. And then one interesting kind of unique feature is that you can drop a self-signed certificate into your application package, set the exclusive trust option in the manifest, and then your application will only use that certificate. So you get the benefit of not actually having to pay $5 to actually buy a certificate or whatever it currently costs. And then, of course, you don't have to worry about if the CA infrastructure gets compromised or something crazy like that, which apparently happens sometimes. And so the next thing to think about is sort of a design level issue. You want to avoid exposing WinRT APIs from the local context out to the web context. So this is very tempting where if you don't really want to worry about sort of all these restrictions in a local context, maybe you just want to have your web content directly drive the webcam, do some interesting things. It's very tempting to build your app like that, and sort of, but you just have to remember that sort of negates the value of the local context as a broker. Compromised content then can just perform actions on behalf of the application or user. So what you really want to do to avoid that situation is build your UI in the local context where that makes sense. So for example, if you were building an application that could, say, burn a CD, it makes sense to put that UI for the CD burning in the local context, as opposed to have that driven out from the web context, sort of passing messages into the local context to drive WinRT. As a pen tester, when I audit, the first thing I'll do when I pull down an app to audit it is to look for, what's the attack surface of messages coming into the local context, like what can they do? So you want to actively audit and limit the attack surface exposed from the local context to the web context. And so the next thing to talk about is, this is really simple mitigation, just to be aware of. You can validate messages coming in from the web context to the local context. You really should do that, because you never really know where a frame is pointed to. If you navigate a particular frame in your application somewhere, it may not be navigated to the same place when it sends you a message, depending on if the user navigated that frame somewhere. So you should do that validation. It's very simple. You can just check the origin property of the message that you get in, and of course, you could sort of do the reverse of that as well. You can set the target of any message you send, as opposed to sending messages to anybody. And so other considerations, so there is this MS Apex Web protocol scheme, which is intended to take application package content and display it within the web context. You should just be aware that cookies and HTML5 local storage are, in that case, shared with the local context. So it's not really sort of a sandboxed environment. You can use the windows.storage.application data API to keep sensitive data isolated to the local context and avoid that sort of that sharing problem there. If that's something, it might be of interest to you if you happen to be leveraging this MS Apex Web protocol. In general, you want to use JavaScript libraries with caution. You never really know where they're going to be putting content in the DOM after you disable, or after they may be disabling sanitization. So you should think about using toStatic HTML if you believe they're going to actually put that markup into the DOM. You don't want to compress or minify your JavaScript. It doesn't really get the benefit you might expect. And you want to watch for inadvertent file bundling. So we've seen like PFX files landing in application packages, private keys, that kind of thing. You probably want to make sure you know exactly what's going into your application package. And then XAML applications. So we don't have a lot of these injection scenarios within XAML applications that we've seen. They do a pretty good job of separating, the model does a pretty good job of separating markup from script. However, there are still some interesting issues that may pop up. This is something that Manuel Caballero found fairly recently, where you can host a web view control within your XAML app to display and render content. And it might be the case that your application makes trust decisions based on what's within that frame. You really need to be careful about that and not trust content or not trust information you get back from this invoke script API, because what it essentially does is calls into the frame and performs some operation. It calls some script. That markup within the frame can sort of override anything. So in this case, this particular example, it's calling the eval method of the sort of the native eval method. It's intending to call the native eval method of the page in a frame to get the location.href, the current location of that frame. And it may be making, you might think that, okay, you could grab the location of this frame and then make a security decision based on that. But you really have to be careful here, because you can imagine that content, if you don't trust it, within the frame could just overwrite the eval method and then set an arbitrary location, and then you're making a security decision that is not quite accurate. So I think it's back to Crispin.
Just before I move into cloud security, I forgot a particular bug pathology with regard to networking. There you are developing your application, and of course you're using a test server that's not on the internet, and so they're all on your own private network. And you discover that your app can't talk to your server without the private network capability, so you turn that on in development. And then you go and ship it, but you forgot to turn off private network. You kind of want to turn it off because that private network is a very big threat. We don't want a lot of apps in the store with private network, and if you were building truly an internet client, you don't need it. You just needed it for testing. So be sure to take like a laptop home and test it on your real server before shipping. So cloud security, and I mean broadly anything where there's a server involved, not necessarily just that you hosted it with Azure or something. It's natural to think of your cloud service and your client app as just two parts of a whole. That's really one application. They're working together. The client would never try and hack the server, right? You wrote that code. Well, no. The attackers don't have to use your client. They can use their own client. They can hack up your client and do nasty things to your server. None of your client-side rules are really enforceable because the bad guy with a machine and some client-ish thing of yours can do whatever they want. There's no way to enforce that. So if you want rules to be enforced, then the cloud server has to enforce them. You always want to identify and authenticate your users in the cloud. You can't assume that just because they're using your client, they'll be well behaved. The identification and authentication is so that if somebody goes spammy, that you can go, yeah, let's clean out all of his posts because they're all pointing to that dubious browsing site over there. Again, the rules in the client are just guidelines. You need to enforce this stuff in the server. Authentication options. There's a feature in Windows 8 called Cred Locker that will securely store clear text username password pairs. If you want to have your own naming scheme and password at the website, the old school stuff, go for it. If you want to use OAuth, there's an authentication broker. So the user can go give their Facebook password not to your app but to the OAuth broker and then permit your app to access, say, the user's Facebook pictures. That'll work. The shared user certificates capability, that lights up both stored shared user certificates and smart cards. So if you want to use StrongAuth, like Blizzard, I think, was distributing tokens at some point for your World of Warcraft gaming. That's how you turn it on. The enterprise auth capability, as I said, allows your app to authenticate over the wire as the logged in domain user. If you're building a enterprise application, that's perfect for you, but it only works on domain joined machines. Come on. There we go. Sharing data. Windows 8 apps are isolated by design so that it keeps them from meddling with each other. But it's nice that you want to be able to share data from one to another. This is really cool that I can take something that I saw on Twitter and Facebook it and vice versa. Windows 8 has these sharing contracts. If two apps implement the same contract, then the share charm will hook them up. It's kind of like Unix pipes, but for real people. Share provides this lightweight, in-context, universally accessible, all-singing, all-dancing connectivity between apps. A share source app provides data. I have a GIF to give. Does anybody want it? And a share target says it will consume data. Yes, I like GIFs. They're tasty. And so the app says, I have something to share. The user clicks the share charm. The user picks a target app, and the target app goes, treats, and the data goes in. The same thing with Clipboard. You can cut and paste data from one app to another. But sharing has its risks. Your app has to carefully parse everything that comes in from a sharing contract, just as if it came from the network, because it could be hostile. When you sign up for a sharing target, you are signing up for any app can cram anything down your throat, and you get to deal with it. So if you don't have scenarios that require being a sharing target, then don't implement it. My favorite scenario for that is banking apps. Nobody tweets to their banking app, please. Let's have the banking apps just not be targets. And the social apps, they can implement the sharing stuff. That would be great. Cut and paste. The clipboard is the same threat. It's very handy that you can cut and paste text from one place to another. But when you paste, you don't know what it is. It could be anything. So be careful when you implement paste. And you implement paste. It's not system. The user types control V. That just goes to your app that calls an API that says, yes, please read whatever's on the clipboard and stick it here. File type associations. You can register your app as being a file handler for a given file type like .foo. This is fantastic if your app is a foo editor. The problem is that any app can cram any .foo file down your throat. It just goes, yeah, someone please open this malware malformed .foo, and it goes to you, and you open it. So be careful when you're opening and parsing stuff like that. You could get pwned that way. You can also register as a protocol handler where you have the same threat. So what's really new here? Apps have always had to secure themselves against attack. So what is new in this platform? And what's new is that there's new defenses. All the other guys are isolated, so they don't get to just directly go and thread inject your memory. All of the nice memory mitigations are turned on for you. So a lot of the base level threat has been taken care of, and now you need to focus on your network interactions, like all of David's content about interacting with the web carefully, and the sharing interactions. And there's new threats. They're not so much new threats as new worthy threats, that before your app was completely exposed to every other app on the machine. And now there's a wall around everybody, so now I'm not so exposed to those other apps on the machine, just this sharing thing. So now it's worth defending your app against neighbor apps, because for the first time you actually have a defense against that. Wrapping up, there's our additional resources. I assume the slides go out somewhere. I'm Crispin at Microsoft.
D. Ross.
Thank you very much.